Hi, in this video we'll be looking at CPM schedule calculations. So you will learn how to calculate a CPM by doing a forward pass, a backward pass through the network, how to do float calculations, how to identify critical activities, and then finally how to deal with imposed start and finish dates. So the first step in calculation is to prepare a network diagram, and a PDM or a precedence diagramming method uses something like this. So each activity is shown as a node. In this case, you see the box over here. So there are these 6 activities: A, B, C, D, E, and F. And there's a start and a finish, which is both of these are milestones. The relationship between these activities are shown through edges, which are these lines, and there are various types of relationships. In a network, once you have the network drawn with something like this, the next step that you do is you put in the duration of each activity. So you notice that each activity now has a duration. So C is 2, D is 6, so on and so forth. Now given this network, what we want to do is we want to calculate the early dates, which means we want to find out when each activity should be starting, what is the earliest date it can start, and what is the earliest date that an activity can finish. Then we want to go and find out what are the latest dates, which are late dates. So we calculate the late start and late finish dates, and then the floats, and finally the critical path. So if you see a very simple network that I've drawn over here, I've labeled the dates, and this is typically the convention that is used. So on the top you put in the early date, which is the ES is early start, EF is early finish, and on the bottom you have the late dates, which is late start and late finish. And finally, also at the bottom you'll be writing the float. So the calculation happens in a sequence of 3 steps. In the first step, you start with the first activity, and given the early start for an activity, you want to figure out the early finish for that activity. So the formula is as follows: early finish is equal to early start plus duration of the activity minus 1. So for example, if I look at this activity and the early start was let's say 1, and it is a 10-day activity, then it would be 1 plus 10, that's 11, minus 1 is 10. So early start would be 1 and early finish would become 10. So you repeat the same calculation. Now if you are once to do these calculations, so let's say we did so we've identified 1 here, and now we know this is 10. So what happens next? What happens next in the forward pass is that you look at the next activity that's coming. So the next activity has to start in the next date, which means if we finish on the 10th, the next activity can start on the 11th. So we'll put 11 over here, and let's assume that this is an activity that takes 5 days. So 5 plus 1 is 16, minus 1 is 15, so that would be the finish date. So that's the forward pass. So in this manner, we've calculated the early starts and the early finish dates. Now, to do the backward pass, what you do is you take the early finish. In this case, there are only 2 activities, so the early finish for this is 15. So I'll use the same number over here. Now we have the early finish, that becomes also the late finish. And now the calculation is so the calculation is now, given the late finish, we want to calculate the late start. So that becomes this formula, which is late finish minus duration plus 1. So it would be minus 5, which is 10 plus 1, so that's 11. And now in the backward pass, you go to the previous activity, if this has a late start of 11, then the late finish of the activity before it would be 1 day earlier. So that would become 10. And again, 10 minus 10 plus 1, that's 1. So that's the backward pass. That's basically how the calculation happens. And the last step in this process is to calculate the floats. The floats are simply the difference between the early start and the late start and the early start. So in this case, late start minus early start is 0. So the float here is 0. And the float here is 11 minus 11, and that's also 0. So that's it. So it's 3 steps. So you do the forward pass, the backward pass, and then you do the floats. Let's look at a slightly bigger example. So in this case, we have 7 activities, and let's apply this method to do the calculation. So we start by looking at the first activity. So first activity start. This is a milestone. Remember, when you have a milestone activity does not have a duration. So if the milestone is on the first, then the next activity would have the same date because milestone has no duration. So I'll put 1 here, and notice it's also connected to this activity, so I'll put 1. So to calculate the early finish, it would be 1 plus 3, that's 4 minus 1, so that becomes 3 again. Now I can go to the next activity. If this is finishing on the 3rd, the next available day for work is the 4th. So we go to 4th, and then 4 plus 5 is 9 minus 1, that becomes 8. Now if this is finishing on the 8th, the next available date is 9, so that becomes 9. And then 9 plus 2, 11 minus 1, that's 10. Okay. Now I'm not going to go further because I see that the next activity has 2 predecessors. So I can't work on this activity unless I also know the answer from this activity. So I'll go back here. And this is 1 plus 4, that's 5 minus 1, that becomes 4. Next available date 5th. And then that's 13. And 8, 5 plus 8, 13 minus 1, that's 12. Okay, now let's see what happens. Now we have 2 dates. We have 10, C is finishing on 10, and F is finishing on the 12th. So obviously we can't start the work unless both of them are finished, because the T requires both of them to be finished. So you have to take the maximum of these, and that's what this formula tells you. When there's more than one predecessor, pick the maximum. So the maximum is 12. And if the maximum is 12, then the next day after 12 is 13. So we'll put 13 over here. And also in this case, it's 13. And then, so this becomes, that's 19 minus 1, that becomes 18. And this becomes, that would be 15 minus 1, and that becomes 14. And again, the same formula. So what is the maximum over here? The maximum is 18. But remember, now we are at a milestone. When you're at a milestone, you use the same date. You don't do the next day. You just use the same date. So in this case, the finish is going to be on the 18th. So that completes our forward pass. So now if you see, we've calculated all the early start and early finish dates. And we can also now state that this project is going to take 18 days to complete. Okay, so now let's go to the next step. The next step is we want to do the backward pass. Okay, so for the backward pass, we use, so we know that the finish date that we calculated from is 18, and that's going to be the same date that we use for the backward pass. Now we put 18 on both these activities because they're connected to this finish milestone. So that comes to 18. Let's now see the calculation. So the calculation now says to calculate the early starts, in this case, we need to take the late finish minus duration plus 1. So if you do minus duration, that would be 16 plus 1, so that would become 17. In this case, it would be 18 minus 6, so, and the 12 plus 1 is 13. Okay, now I have two activities that are connected to F. So I have to decide what the late finish here should be. And the late finish here should be the minimum. So you see that formula over here? So when you have more than one, you pick the minimum. So the minimum out of these is 13. And if 1 day before 13 is what we're going to pick, so that becomes 12. And then 12 minus 8, 4 plus 1, that becomes 5. And the day before that is 4, so 1 day before. And then again, that's 4 minus 4 plus 1, that's 1. So on this side, you have 13, so we put again 12 here, because this was 13, so 1 day before is 12. And 12 minus 2 is 10, plus 1 is 11. And again here, this becomes 1 day earlier, that's 10. 10 minus 5 is 5 plus 1 is 6. This becomes 5. And 5 minus 3 is 2 plus 1 is 3. Okay, so now at the start, you can see that there are two activities that are connected to the start. And what do we pick? Well, our rule says you pick the smaller one from the minimum, so we pick 1. So that's the calculation. So now we've done the backward pass, and in the backward pass we've calculated the late finishes and the late starts. So now all the 4 dates that we require has been calculated. So all the 4 dates are now calculated. The last step now is to calculate the floats. So the float is a simple formula. Of float is a late start minus early start. So we start here, the late start is 3, early start is 1, so the difference is 2. Difference here is also, float is 2, float here is 2. The float here is 0, 13 minus 13 is 0, so 0 here. And let's look here. So here also the float is 0, 5 minus 5, 0, and 17 minus 13 is 4. Okay, so if you notice something interesting here, you have some activities that have float and some activities that have 0 float. Now if an activity has a float, for instance A is showing a float of 2, what does that mean? It means that if the early start for A is 1. However, A can also start as late as the 3rd without affecting the schedule because it has floats. Okay, but if you look at some other activity like here, so this is E has an early start of 1 and it also has a late start of 1. That means this activity does not have any float, it has 0 float. If there's a delay in this activity, it will delay the project. Okay, and that's why anything that has a 0 float is on the considered on the critical path. So to find the critical path, what you have to do is you identify all the activities that have a 0 float, okay, and you connect them up, and that shows you the critical path. So in this case, the critical path starts up from start, goes to activity E, goes to activity F, and then D, and then finish. So that is what the critical path is, and all the activities in the critical path are considered critical activities. Now it is possible that you could have multiple critical paths, so it really depends on the nature of the network that you have. Okay, and the final thing is, how do you deal with imposed start or imposed finish dates? It's very simple. All you have to do is if you have an imposed start date, then you take that as the first date. So if, let's say I had an imposed start of 10 over here, then I would calculate everything starting from 10. So this would become 10, and 10 plus 13 minus 1, 12. So the calculation is pretty much the same. There's no difference in the calculation. The only difference is that you use an imposed start, and instead of 1, you're using that date over there. And how do you deal with the imposed finish? With the imposed finish also, it's the same thing. Instead of using we calculated early finish using the forward pass. Let's say it was 18. Instead of 18, if I had an imposed finish, let's say my imposed finish was 17, then simply I would take 17 and then use this to do the backward pass. So this would become 17, and 17 minus 6 is 11, so this becomes plus 112. That's the only difference that happens. So there's no other difference. Use the imposed start or a finish. Imposed start affects the forward pass. Imposed finish will affect the backward pass. Also remember that when you have an imposed finish, sometimes you will get negative floats. That's possible. If you have negative floats, so we saw zero float, but you can also get a negative float. And if you see a negative float, that simply means that this activity is not only critical, but any negative float in the schedule tells you that the project is going to be delayed. So if you have a -2 negative float in your project, that means your project's already delayed by 2 days. It's not going to meet the deadline that you want. So in our case, if we said that we have 18 as the finish date of this schedule, if we do an imposed finish of 17, then the negative float would become -1, and that means that this is not practical. The way our schedule looks right now, it takes 18 days, and if we're trying to finish it in 17, that's not possible. We'll have to save 1 day somewhere. So that's how you use negative floats. So just to summarize what we've discussed in this lecture, there are 3 steps that you do in a network calculation. The first step is to do a forward pass. In a forward pass, you start with the start milestone. You then calculate the early start and the early finish for all the activities in the network. Next, you do a backward pass. In a backward pass, you start with the finish date, early finish, and then you work backwards and you calculate the late finish and the late start dates. Step 3, you have to calculate the floats. And floats are simply the difference between the late start and the early start. Anytime that you have a float that is 0 or less, that means that activity is critical. Once you've done the float calculations, you can then highlight all the activities that have 0 or minus float, and those activities form the critical path in your network. Okay? So thank you, and try out these calculations on your own.